Okay, in this video we're going to be doing some more examples on recurring decimals as fractions. So we're going to do the technique that we actually learned in the last video to convert these decimal numbers into fractions. So for the first example here, we have a number that is essentially just repeating 8. So we know if we set this equal to x, and then we can simply multiply this by 10. So that's going to become 8.888 and so on. And if we subtract those two together, we're going to get the following. Because the 8 is repeating to infinity, essentially all these 8s are going to cancel out. So we're going to be left with 8. Now we have 9x on the left hand side, and then if we rearrange this equation, we get 8 or 9. So we can check that in our calculator, and indeed we get the recurrent decimal. So that's the answer for that one. Now for this one, we have a x equals 9.757575 and so on. So the repeating unit is actually 2 digits. We're going to have 7 and 5. So the logical step here is to multiply by 100 so that we have 975.75. So we have those repeating decimals. And now we're going to subtract those two. So 100x minus x. All these 7 5s here, that all the decimal places are going to cancel out. So we're going to be left with 975 minus 9, which is actually going to be 966. Okay? And now this side we're going to have 99x on 966, and then that means that we're just going to write therefore here. It's going to be 966 over 99. And let's see what else that comes here. So let's check in our calculators, and indeed that's what it becomes. In this particular case, we can actually divide both, because both are multiples of 3, we can actually divide them, so we can simplify the fraction to 322 on 33. But indeed we're gonna get this recurring decimal. For this one we have 3 decimal places, so same procedure as before. The pattern has 3 digits repeating, 1 through 2, so on. Now obviously we want to try to grab one single pattern, so we're going to have to multiply it by 1000. So it's going to become 132.132. So these units are going to cancel out. 1000x minus x. All of this is going to come down to 132. And then notice what happens on this side. We're going to have 999x equals to 132, which simply means that x is going to be 132 on 999. And at this point it looks like both of these numbers are divisible by 3, because this one is a multiple of 3. This one, let's see, the sum of the digits is going to be 6. So we should actually be able to divide each of those by 3. So that's going to be simplified to 44 on 333. And if we put that in the calculator, we're going to get this number again. Now, notice the really interesting thing here, right? So if we were to divide 132 by 1000, we would simply get 0.132. So it would be a non-recurring decimal. But because we have basically subtracted just one unit from the denominator, we get a recurring decimal in which the decimals are the same, but now they're repeating to infinity. So that's a very interesting thing that we have noticed here. Okay, let's do the next one. So same procedure as before. We have x equals 13.8125, 8125, and so on. Now in this case we need to grab 4 digits, so that means that we need to multiply this by 10,000. So this is going to be a little bit trickier. So we're going to move the decimal point 4 places to the right, so 8125. Then we have 8125 repeating. So decimal places are going to cancel out. So we're gonna subtract this minus that. It's gonna be this minus 13. So we have 1381. It's gonna be 12. Let's check. We add 13 to that. Yep, 25. And now x is gonna be, so we know this is gonna be 9,999. So let's check that in our calculators. And yes, indeed we get that number. And we cannot really simplify this any further. Now let's do a tricky problem. So all of those ones that I gave you are pretty easy because you just need to multiply something by enough spaces. So in the end you always get a whole number when you do the subtraction part. Now let's do this example here. We have the following number, 14.13, and then the 56 is going to repeat to infinity, right? So what we have here is, okay, so we could multiply this by something like 1000 just to get those first two digits, at least in the repeating sequence, into our number. But then we run into the problem that that's not really gonna become a whole number. So let's see how we can do that. Okay, so I claim that I'm gonna do a multiplication by let's see what we can do here. I'm just gonna do multiplication by 100. So 14, so it's gonna be 1413.5656. And the reason for that is that I want to still get this recurring decimal to cancel out, but I want to keep this number as small as possible so that we can simplify the fraction in the end. So if we start from here, the first thing we notice is that, okay, so this and that are gonna subtract and give us two decimal places, but everything after that, so this whole portion here, this whole portion there, are gonna cancel out. So what we can do here is we can say, okay, 99x, so basically this minus that, is gonna be equal to this minus 14, which is gonna be 1399 point. Okay, so we have, let me just do it in this fashion. And then we have the 56 minus the 13, that's gonna be 43. This one is quite tricky, but we know, okay, we can easily convert that to a decimal because, come on, we just multiplied that by 100. So we're gonna get 99x equals to 139943 over 100. Remember that we need to still keep the same number. So we're converting this one to a fraction first, and now we can say x is gonna be equal to 139,943 over 100 times 99, which is gonna be 9,900. And just for the sake of argument, let's check that against our calculator to see what we get. And indeed we get the same number. So hopefully this video has shown you how to do some more complicated examples of converting recurring decimals as fractions, and we're gonna do some more things with rational numbers in the next few videos.